Hello everyone, and welcome to what we're calling our Organic Lab Odyssey. I'm Naji Mansour.
And I'm Sirine Bahem. In this podcast, we won't be sharing information on chemistry itself, but the experience of going through this course. We're reaching the end of our Chem 225 Organic Lab, the final mixture identification, the last experimental steps, the whole thing. And we realize it's worth talking about. Can you tell us why, Naji?
Yes, of course. Chem 225 is interesting because it's one of the few courses where you're not just following a recipe. You're actually doing detective work. You're building a case based on observations, and you do it mostly on your own.
Exactly. And it's intense in ways you don't expect. Not dramatic, just genuinely demanding. So, we thought, why not talk about the journey? The stress, the doubt, the small wins, the things you learn without realizing it.
So this isn't a guide or a how-to. It's simply our honest experience, the good parts, the frustrating parts, and all the lessons that stick with you long after the course ends.
The three unknowns feel like the beginning of a long story. I remember getting my vials, a white powder, a yellow solid, and a transparent liquid. Innocent looking. It tricks you into thinking it's going to be straightforward.
It was actually the same for me. I got a clear liquid, an off-white powder, and pink crystals as my unknowns. It felt pretty simple at first, but then you open Schreiner's Guide to Identifying Organic Compounds. The book is massive. It's like being handed a map with 1,000 possible destinations, but no directions on where to start.
The steps seem simple at first, but the moment you begin, each question opens new questions and doubts. Is it soluble in water? Maybe. Is this a positive result? You get into this world of dilemma where you need to decide simply between yes or no.
And don't get me started on the sample size. That teaches you discipline. Every milligram matters. You suddenly understand why instructors emphasize micro scale. I used too much material on my derivative synthesis attempt and immediately realized I couldn't afford to do that again.
You know, there's a moment in the early weeks where you acknowledge this is not about reading the manual, go into the lab and following procedures for reactions as robots. It's about making decisions based on imperfect information. You're slowly matching all clues from faint color changes, borderline solubility, melting points that aren't perfectly sharp.
And let's talk about melting points. I mean, when you finally get a clean melting point that matches the literature, that's a moment of pure relief. For me, it was one of the first times I thought maybe things are turning out better than I expected.
But then, you run another test, and the confidence evaporates. Personally, I can't count how many times I ask myself and repeat the test to reach a final answer.
But let's delve a bit deeper into what we did. I remember you telling me about your unknowns. You once told me you got a nitrile, an ester, and a ketone. Could you tell us how you came to this conclusion?
Well, when we first got the unknowns, I performed a set of solubility tests on each of them, in order to narrow down the range of possible unknowns. I then performed the sodium fusion test to determine if I had any halogens or nitrogens, which led me to testing for various functional groups. At the end, my unknowns turned out to be a nitrile, a ketone, and an ester. And to answer your question, I was able to prove my theory for each compound by matching my IR peaks with the functional group. I felt very relieved when I confirmed my unknowns. Don't you agree?
Exactly, I do. But then comes the real challenge, synthesizing a derivative. You've built your hypothesis, you think you know your compound, and now you have to prove it. For me, this was the part that gave me the most trouble. One of my unknowns, which I eventually figured out was diisobutylamine, just refused to give me a derivative. I mean, I tried 9 different reactions, including 3 that I pulled from sources outside the course textbook, just to get something to stick. In the end, I got a synthesis procedure from another organic chemistry textbook and was able to make the ammonium picrite salt. In the process, you start to learn the small things, how scratching glass helps with crystallization, or how gentle heating changes everything. Things that aren't always written down, but come from actually doing the work.
I can relate to that actually. I almost gave up trials when my first derivative didn't form at all, but I searched in resources outside our lab's book, and it occurred to me, experiments don't exist to confirm your expectations. They challenge you. That's where real learning happens. But what about the anxiety when submitting the final report?
While I think the preliminary report certainly helped in putting us on the right path, I still felt a bit anxious when filling out the final report. The evidence file that Dr. Kaafarani sent us was certainly a big help, as I used the H and CNMR as well as the MS spectrum to completely confirm my unknown's identity, which put my mind at ease.
Looking back, dealing with unknowns taught me how to think like a scientist, to question, observe, and adapt. How to adapt? Well, we had to do research most of the time to understand the clues.
And once you survive the unknown part, you start thinking, okay, I know how this works now. And that's when they hand you the mixture, a true test of judgment.
It's a completely different experience. And that second part, we have two unknowns dissolved in a solvent, and they're mixed together. The separation alone becomes a whole project.
My first moment of panic came during the extraction. I only got one A2 unknown the first try. I actually had to repeat the extraction with that little initial mixture I had reserved, and then ended up getting the second one, which turned out to be of the I solubility class. These were the moments when the course really forces you into decision making. Is it decomposition? Could my unknown have interacted with an impurity or contaminated glassware? I was sure I had washed everything thoroughly though. This way the course forces you to interpret what's happening as it happens.
A major challenge for me was also the extraction. I had this paste-like residue which wouldn't dissolve in diethyl ether. Following the steps for extraction was easy, but you never know what you really have to deal with. It was like a strange surprise effect for me, personally. And the tricky part, where I had to repeat the whole process of separation to finally see my two unknowns.
The first time I saw an emulsion, I thought I had ruined everything. Just this cloudy, stubborn layer that refuses to separate. And if you hadn't done research, you'd just be stuck there, gently swirling the funnel, hoping something changes.
The real mental load comes after the separation, because now you're running two identification processes at the same time. Suddenly, your notebook is the backbone of everything. Labeling, organizing, tracking which data belongs to which unknown. It's so easy to mix things up.
And nothing is more stressful than when your data doesn't match expectations. A melting point that's too low, a test that's inconclusive, a result that contradicts your earlier tests. You start to question everything. Did I separate properly? Is the sample impure? Did I misread something?
But that's where the mixture teaches you the most, because you're not just running experiments. You're interpreting real results with real uncertainty. It becomes true problem solving.
It feels like building two separate cases. You're gathering clues, comparing, ruling out possibilities, confirming with derivatives and melting points. But at the end of the day, it's methodical and flexible. You have to adjust constantly.
And the best feeling? When both compounds finally make sense, when the results converge and the story fits. It's like solving a long, complicated puzzle.
After everything, the confusion, the retests, the delayed crystal formations, what stays with you isn't the structures or the reactions, it's the way you learn to handle uncertainty.
Chem 225 teaches you active patience, not sitting and waiting, but observing, thinking, and analyzing, the patience of doing things carefully, because you know the outcomes depends on it.
It also teaches resilience. You learn that a failed test isn't the end. There's always another way to verify, another angle to consider.
And it gives you confidence, not because everything went perfectly. Actually, the opposite, because you learned how to navigate imperfect results, unclear tests, and unexpected outcomes.
The course turns you into your own problem solver. You rely on your own judgment, and you learn to trust your ability to reason through evidence.
And honestly, that's a skill that lasts longer than any compound you identify. What I value the most as future scientist is the opportunity or the very first steps of research performed in this lab. So if anyone listening is about to take this course, here's what we tell you. Don't be scared of the unknowns. They are meant to challenge you, not defeat you.
Embrace the process. Work carefully. Trust your eyes, trust your notes, and trust your reasoning.
Be curious. Compare results. Celebrate even the small successful steps, because they matter. You will see how all your hard work makes sense by the end.
At the end of the day, the mixture can be solved, the unknown can be identified, and you'll come out of the course much more confident than when you walked in.
You might feel an emotional roller coaster in this journey, from confidence, trials, denial, and then victory, with a perfect final report, a typical organic lab cycle. Now, if you'll excuse us, we have a very long report to write.
Naturally. Thanks for listening, and good luck on your own organic odyssey.